Good morning, everyone. Good morning. Hope all is well. As always, want to give everybody a chance to get in, so let's give them a few seconds.
Good morning.
Good morning. Good morning. How's it going?
It's going all right. How you doing?
I wish I had another day. You know, weekends always seem a little short, even with the holiday, but I'm good, man. I'm glad to be here. All right. I think we got like two people trying to connect, but we'll go ahead and just talk a little bit, see if we can draw a little time out till they get on. So, like I said, good morning. Hope all is well. Hope everybody had a great weekend, great holiday. Everybody's ready to knock out this week. We're going to get into 161, not 161. We're going to get into chapter 1.3, 1.1 anyway. We'll get in there in a second. I know we're starting off with our complex conjugates. So I didn't forget that. So before I go ahead and do that, anybody have any general questions, concerns before we go to your room? Everybody good? All right, where did my notes go? So make sure, yeah, we did add in, subtract, and multiply. So we are still in section 1.4. Last class we finished with, hold on one second. All right, last time we ended with addition, subtract, and multiplying complex numbers. So now we're looking at complex conjugates. All right, so your complex conjugate is just simply changing the sign of your imaginary part. So if we have a plus bi, the complex conjugate of a plus bi is a minus bi. So you're just changing the sign of your imaginary part. All right. All right, so here are a few examples. And notice I have the arrow going back and forth because, if you had a minus bi, then the complex conjugate would be a plus bi. So if we have 5 plus 3i, complex conjugate, 5 minus 3i, notice the real part stays the same. It's just the imaginary sign that changes. Negative 8 minus 11i, negative 8 plus 11i. Then if I just had 23i, the complex conjugate would be negative 23i. All right. Any problems with that? All right, can I scroll up? All right, so last class, like I said, when we were dealing with this section, we did add, subtract, and multiplying, dividing complex numbers. So now, add, subtract, and multiplying complex numbers. So now we're looking at dividing complex numbers and what it means to divide a complex number. So we have 3i over 4 plus I. So the way we're going to take care of dividing these complex numbers is to multiply the top and bottom by the complex conjugate of the denominator. So that's what I said right here. We're going to multiply top and bottom by the complex conjugate of the denominator. And so we have 4 plus I in our denominator. We're going to multiply top and bottom by 4 minus I. All right. So it's basically a denominator. So that's what I did right here. Multiplying 3i times 4 minus I and 4 plus I times 4 minus I. So right here is me multiplying the numerators. So notice we have 3i times 4 minus I. I did my distribution. 3i times 4 is 12i. And then, oh, let me do that. Okay. Then 3i times negative I is 3i squared. So don't forget from last class, we mentioned that I squared would not be a part of your final answer because I squared reduces down to -1. And we have -3 times -1, which is +3. And then we have 12i plus 3. And of course, to write it in standard form, we mentioned before as well, you put your real part first, then your imaginary part. All right, questions on the numerator and what we did. All right, so in our denominator over here, we have to do a binomial distribution, 4 plus I times 4 minus I. And so that would be 16 minus 4i plus 4i minus I squared. And you multiply that out. Now, the reason why, or what happens when you multiply complex conjugates is that your middle term should cancel. So that's why we initiated the conversation of complex conjugates first, because multiplying complex conjugates will get rid of the imaginary part. And so that removes the imaginary part in our denominator. So that 4i and 4i will cancel because it's negative 4i plus 4i. I squared once again is -1. 16 minus -1 is, yeah, 16 minus -1 is 16 plus 1, which is 17. So any questions on anything before we finish the problem off? Any questions on the multiplication, simplification of our numerator and our denominator? All right, everybody good? All right, so then we go ahead and put that back. That's what I have right here in the dark. Oh, I still have my eraser on. Over here in the dark blue. So that 3 plus 12i, place it over 17. Now, when you do write your imaginary or your complex numbers, they do want you to separate your real from your imaginary. And that's what we did right here. So that 17 goes into each term. It's 3 over 17 plus 12i over 17. And that's your answer. Any questions? Make sure we're all right. All right, now scroll up. Am I still copying? All right. So before we do the next examples, one thing you always want to hold true to, if I have the square root of -b, and even if I can't simplify b under the radical, I still can simplify the fact that I have a square root of a negative. So I can bring it out as an I and leave the b under the radical. So one thing we want to hold true to is before you simplify or calculate, we want to take out the I first. We want to take out the I first. And so in the green, I'm going to show you reasons for that. Just give you a chance to write. All right. So if I had the square root of -25 times the square root of -4, if I were to multiply them in their current state, in other words, square root of -25 times the square root of -4, -25 times -4 is +100. Then that would give me the square root of 100, which is 10. And so that's incorrect. So the first thing you want to do, we hold true to this right here. Before I go to multiply, simplify, calculate, take out the i's first. So the square root of negative 25 will be I square root of 25. Square root of negative 4 will be I square root of 4. Now I can multiply my expressions together. I times I will give me I squared. 25 times 4 will give me 100 down bottom, under the radical. And then simplifying that will give me negative 10. All right, so you see that our answer is actually negative 10 instead of positive 10. Over here in the blue is just another way of doing the same thing. It's just that we simplify all the way down. Square root of negative 25 is 5i. Square root of negative 4 is 2i. Multiply those together, we still get our negative 10. So there's just two different ways of simplifying the same expression. It's just that the first thing you have to do is remember that you have to bring the I out first before you go to multiply anything. All right. Any questions? All right, can I scroll up? Very good. All right, so before we go over here, let's look at what we have in the red over here. So I just want to make sure I emphasize what you can and or cannot add or subtract from each other. When you're dealing with these radicals, and did I write it anywhere down here? No, I didn't. So when you're dealing with these radicals, you have to have the same index on your radical and the same radicand. That's what's under the radical. So in other words, if I look at the square root of 5, this is my index. So let's put cube root so I can have a number right there. This is my index. And this is my radicand. So in order for me to add terms, this index and this radicand have to be the same or I cannot add them together. So looking at this first one right here, I have 5 square root of 2 plus 3 square root of 2. So I can add those together and get 8 square root of 2. So I had the square root, which is the same in both cases, and then what's under the radical, which is 2, same in both cases. Now in this next one, I have 5 square root of 2, 3 square root of 7. Since I have 2 under here and then 7 under here, I cannot add them together. All right. Next one, 5 square root of 2, 3 cube root of 2. Well, this time the indexes are different, so I can't add them together. Basically, we're talking about adding like terms. Everything has to be the same, other than the number that's sitting out front, completely out front, in order for us to add them together. And then here, what stops us from adding them together is the fact that this is imaginary and this is real. So you can't add those together. So when you look at a problem like this, you cannot simplify in its current state. We're talking about adding, when you're talking about adding and subtracting, you have to have the same radical, the index of your radical, and the same radicand. That's the number that's under the radical in order for you to add terms together. So we see in this case, we have the same radical or the index of a radical. But now we have to look at what's under the number and say, is there a way for us to break this down to have the same number under that radical? So before we go any further and look to do that, are there any questions on anything that I've said?
So right now is the index, is it 0 or is it 1?
It's 2. Yep. When you don't see anything, they assume you know there's a 2 there for the square root.
Oh, okay, I got it.
Yep. Good question. Good question. So there's never a 0. There's never 1. It starts at 2 and goes up. So it can be 2, 3, 4, 5. It can be 100. But there's never a 0 or 1. It always starts at 2 and goes up. And you'll never see 2. They assume you'll know there's a 2 there. So as far as numbers are concerned, The lowest number you'll see there is a 3. And then they'll go up from there. You have cube root, fourth root, all the way up to, like I said, whatever root you want. Just that when you see nothing there, they assume you know there's a 2 there. And then from there, you do have to signify with other radicals. So yeah, good question, good question. Anything else before we look to do this problem right here? Like I said, this was just an example to emphasize what we can and cannot do. All right.
I'm sorry, quick question.
Mm-hmm.
Coming from negative numbers, like
Mhm.
I'm a little confused on where they're coming from.
When you say coming, what you talking about right here?
Yeah, like where would the I come from in that problem?
The square root of a negative.
Okay, that's
So if I had the square root of -7, that would be I square root of +7. Yeah. So whenever you have the square root of a negative, just the square root of -1 is I. So yeah, square root of -1 is I. All right. So hopefully that answered your question. Just want to make sure I was.
Yeah, it did. Thank you.
Okay, cool. All right. So let's look at breaking down each one of these numbers independently and see if we can create a situation where we can combine these two numbers by subtraction. So the first one is square root of -18. And so I have the breakdown right here. So we talked about this last class. When you have a number that's not a perfect square, you look for one of the factors and see if they have a factor that is a perfect square. So I would break up 18 into 9 times 2 because I can take the square root of 9. Square root of 9 is 3, and we just finished talking about that negative would turn into I. So that's where we get 3I from. And then the 2 just stays under the radical because I can't do anything with that. All right. So when you look at 18, that's the only one that would work for us. You couldn't use 3 and 6 because you cannot take the square root of 3. You cannot take the square root of 6. You would break it up into factors so that you can take the square root of one of them. And so that's why we broke it up into 9 times 2. Looking at the square root of -8, I would break that up into 4 times 2 because I can take the square root of 4. So taking the square root of -4 will give me 2I, and then I leave the other 2 under the radical. Any questions?
So you're always going to basically divide it by 2 to get like the -4 times 2, the -9 times 2. You're always going to have like a number times 2.
That was just in this scenario. If I had the square root of 500, I can break that up into 100 times 5. Then take the square root of 100, which is 10, and leave the 5 under the radical. So it was just a coincidence between these two because they set it up so that you will be able to add them up together, but that doesn't necessarily have to be the case.
Okay, so then I guess what my question is is there something, what exactly are you trying to find when you do that? Is it like the least common denominator type of thing?
Right. Well, you're looking for the highest number. You know, factors are two numbers that multiply together. Mainly, we're looking for two numbers in this case, two numbers that multiply together to give you this original number right here. So, you know, when you look at 18, you have 1 times 18, 2 times 9, 3 times 6. Now, we're trying to take the square root of 18. So what we're looking at is, are there any factors of 18 that I can take the square root of? When I look at 1 times 18, 2 times 9, 3 times 6, can I take the square root of either one of these numbers? And the answer is yes, I can take the square root of 9. So that means I would use 9 times 2 in my breakdown. Same thing with 500. I want to be able to take the square root of part of 500. So what two numbers will multiply to give me 500? But in the same fashion, I can take the square root of one of those numbers. So 5 times 100 would be the move to make with 500 because I can take the square root of 100. So I'm looking for a factor that's a perfect square of that number.
Got it. Thank you.
All right, that's the problem. All right, so anybody else before we look to finish off this problem? So we've broken down our two numbers Let me erase some of this stuff. So we've broken down our two numbers into these. We have 3i squared root of 2 minus 2i squared root of 2. All right, and so that's where we are right here. 3i squared root of 2 minus 2i squared root of 2. Now I can subtract them. Notice I have, we look at what we have. We have I and I. We have the square root in both cases. And we have 2 that's under the radical in both cases. So we needed all of those to be the same in order for us to be able to subtract the 3 and the 2 that's sitting in the front. So if any of them are different, then I would not be able to move forward. I would just have, whatever the expression is, that's my final answer. But since they are all the same, now I can subtract 3 and 2, and that'll just be 1. So you can write that one of these two ways over here, I square root of 2 or square root of 2i. Just make sure that you don't extend this radical over the I. That would be considered incorrect.
So both of those answers will be okay, like on the test?
Yes. So, and like I said, the only problem that you have to consider is this bottom one right here, because sometimes people make a mistake and extend the radical, like they don't separate it and then write I, maybe you have to hit the arrow to come up out of that symbol or something like that. Depends on how my math lab got you setting it up, come out of the box or whatever the case may be. And then put I, so that I is not included under that radical. So it should accept it if you do that right. All right, everybody okay before we look at another one like that? All right, so here we have -1 plus square root of -5 squared. Let me erase this so we just see what the original problem is. I'll put it back. Yeah, so that is our original problem. We have -1 plus square root of -5 squared. So we talked about how we want to handle this type of problem. First thing we want to do is to pull out the I. Before we go multiplying, we're doing any type of simplification. The first simplification that we want to do is to bring the I out. That represents that square root of negative. So notice that first we had -5, now we don't because it's represented right here in that I. All right. So from there, let stuff go back. We can go ahead and distribute, do our foiling. So it's -1 times -1, -1 times I square root of 5. Then I square root of 5 times -1, I square root of 5 times I square root of 5. And this is the result. 1 minus I square root of 5 minus I square root of 5 plus I squared square root of 25. So that last one, be careful with that. When you multiply these two together, that's I times I, which will give us I squared. Then square root of 5 times square root of 5, which is square root of 25. You just multiply what's under the radicals. All right. Any questions before we go to the next step? All right, so now we want to combine like terms and simplify more if possible. So we have I, or negative I square root of 5 minus I square root of 5. So that would be -2I square root of 5. And then here, I squared, remember we already mentioned before, that's going to just simplify to -1. And then the square root of 25 is 5. And of course, we still have this 1 out here. Then to finish it all, combine your like terms. We have 1 and -5. And that will be -4. So it's -4 minus 2i square root of 5.
How did we get the square root of 25 to -5?
Whenever you multiply, well, not multiply, but when you multiply these two terms. All right, so negative times negative term is positive. I times I is I squared. Then the square root of 5 times the square root of 5 is square root of 25. So you just multiply what's under the radicals. Now, I squared is going to be -1, and then square root of 25 is 5. And so that'll be -5. All right. Anything else? Anything else? All right, can you scroll up? Everybody good? All right, so once again, let me erase this stuff so we can see what the original problem was. No extra stuff. All right, so our original problem is right here, -25 plus square root of -50 minus 15. All right, so what I'm going to do first is simplify the square root of -50. That's what I did over here. So just like I was talking about square root of 500, breaking it up into factors that I can take the square root of, or a factor that I can take the square root of. I'm looking at the square root of -50, and I broke that up into -25 times 2. Once again, it just so happens to have a 2 involved. Remember, that does not have to be the case. So the square root of -25 times 2, the square root of -25, that part breaks down to 5i. Square root of -1 is I, square root of 25 is 5. And then we left the 2 under the radical.
Are all of our answers when it gets to like that part, are they always going to be like square rootable?
That part I cannot guarantee. You know, just like if they gave you the square root of -17, then the only thing you can do with that is bring the I out and leave the 17 under the radical because 17 is prime. So you still could bring the I out because you're taking the square root of negative, but there's no guarantee that they're going to give you a number in which you will always be able to break it down that way. So good question, but there's no guarantee.
All right, thank you.
Yeah, not a problem.
Wait, so when you
Yeah.
put the square root of -25 to 5i, why didn't you just put 5 instead of, or sorry, why didn't you just put 5 and you put 5i down?
Oh, because of the negative under there.
Oh, okay.
Yeah. Now, if that was all positive, oh, yeah, that's okay, fine. Now, if this was all positive, let's say if you had the square root of 50, positive 50, then right, you would not have an I right there. It would just be 5 square root of 2.
All right, gotcha. Just a little bit confused on that.
Yeah, not a problem. Anybody else before we go to the next step? All right. So, erase this. So now we have -25 plus 5i square root of 2. And the next move is to break it up and to distribute that 15 that's in the denominator to each term in your numerator. And that's what we did over here. So that's why I have -25 over 15 plus 5i square root of 2 over 15. And then simplify that. In each case, you can divide both of them by 5. And that gives us -5 over 3 plus I square root of 2 over 3. All right, questions, any questions? All right, we all good before we go to the next thing? All right, so make sure you try these out, try breaking them down. As I always mention, if you have a specific problem that gives you trouble, make sure you bring that problem to class so we can address that one. Because I may pull a problem or an example up and it may not really address the issue that you had with that specific problem. So always write it down or take a picture with your phone, notate it somehow so that we can discuss any problem that you bring to class. All right. So let's look at 1.5. Quadratic equations. So we're going to talk about 4 methods on solving quadratic equations in this section. So that's our general form: ax squared plus bx plus c equal to 0. It's considered a second degree polynomial because our highest exponent on our variable is 2. And it also lets us know how many solutions we should receive. So that'd be 2 solutions that we'll be looking for whenever we solve our quadratic equations. Of course, if I scroll up and you're still copying something, feel free to let me know. Can't see anybody, so I don't know who's writing this stuff. So always feel free to let me know. So the methods that we will cover in this section: first is the zero factor property. Then we have the square root property, completing the square, and then the last one would be the quadratic formula. So now I sent you guys the lectures from last week. I think I said it on Saturday, but I also sent you videos on factoring as well. Make sure that if you are a little shaky on factoring, take a look at those videos. Also, you can get with me either way, but I just thought, I know somebody asked about them, so I just went ahead and sent them to the whole class. But method 1 depends on your ability to factor, and they're coming into this section assuming that you already know how to factor. So make sure that you get your factoring techniques solidified. All right, anybody still doing this? Everybody good? All right, so let's look at the first method, zero factor property. It says if a times b is equal to 0, then that means that a is equal to 0, b is equal to 0, or both. All right, so bottom line, the way we use that to our advantage or to be able to solve these quadratic equations, once you factor your expression, let's say we've already factored to x plus 5, x plus 2, then we can take each piece that's been factored and then set them equal to 0 and solve. And that's how we'll get our 2 solutions. So you take x plus 5, set it equal to 0, subtract 5 from both sides. One of our solutions is x equal to negative 5. And do the same thing with x plus 2. And our other solution is x equal to negative 2. All right, so that's why we have to factor. Factoring puts us in this position right here. Once we factor, then we can set each factored piece equal to 0 and solve. All right, everybody good? All right, so looking at the first one, 4x squared minus 2x equal to 0. So like I said right there in the red, you want to factor it as much as possible. If you're using the zero factor property, you want to factor it as much as possible. So in this case, I can factor out 2x. I can pull 2x out of each term. Don't forget, when it comes to factoring, whatever your factored expression is, if you were to multiply it back out, it should give you what you originally had. If that doesn't happen, then that's not the factorization of that expression. So your factoring is supposed to be the reversal of your multiplication process. All right. So now we factored out 2x from both terms. That's just factored as much as possible. I'm just, once again, just erasing stuff so that we can look at what the result is. So now we would set 2x equal to 0, set 2x minus 1 equal to 0. So that's always the step after you factored as much as possible. You set each one of your factored pieces equal to 0. And then you can solve for x. So in the first one, I'll divide both sides by 2. X is equal to 0. And then in the next one, I'll add 1 to both sides, then divide by 2, and x is equal to 1/2. So both of those will be my solutions. So remember what your solutions are, values that will make your original equation true. So you're asking yourself, when is, my erasure up here, there you go. When is 4x squared minus 2x equal to 0? The answer is when x is equal to 0 or when x is equal to 1/2. So either one of those will work for you. And what you would do is if you want to test it, you just plug it back into your original and it should set one side equal to 0, set the other side equal to 0. So you always can check your solutions. All right. Any questions before we look at the next one? All right, so here we have 2x squared plus 7x equal to 4. Now, our last one had one side equal to 0, so we didn't have to mention it. And don't forget, it's called the zero factor property. So 0 is a part of, and I didn't mention it right here, but 0 is a part of the process. So you want to set one side equal to 0 if that's not the case. So that's what we did here. We have 2x squared plus 7x equal to 4. Set one side equal to 0 by subtracting both sides by 4. And that gives us the expression 2x squared plus 7x minus 4 equal to, and then the equation of equal to 0. All right, so now we want to factor. And whenever we have a trinomial, you want to still have our two sets of binomials, two parentheses of binomials. And so the way you look at it is that your signs, and like I said, I explained all this in that video, but the back sign lets you know where you would start. It tells you that each one of your signs of your parentheses are going to be different. So that's why I have plus and minus. And then I have to use the factors of 2 and then the factors of 4, which is what I have right here. So that's why I have 2x and x, which is 2x squared. Then in the back, 1 times 4, which will give me that 4. So then you would have to check it and make sure you actually get 7 in the middle when you do your when you multiply back out to check. Remember I told you the factorization, when you factor, multiplying it back out is how you would check to see if it's the actual factorization, see if you get what you originally had. So what I would do is use those factors and then multiply it back out to check to see if I actually get 7x in the middle. And so this will work for us. If I were to fold that out, that's 2x squared plus 8x minus 1x minus 4. And then so adding these together will give me a positive 7. So that's what I mean by fold it back out to see what I get originally. All right. Let me erase these. So once you factor, you can set each part equal to 0 now. 2x minus 1 equal to 0, x plus 4 equal to 0. Add 1 to both sides, divide by 2. 1/2 is the first solution, and then in the second one, subtract 4 from both sides. X is equal to -4. Any questions? Any questions?
So as long as one thing in the equation is equal to 0, that's all we need.
So you said one thing equal to 0. What you mean by that?
Like how when we were solving for the equation, the end part was equal to 0. So
Yeah, so you do want to set, yep, before you can start going through your process, you want to set one side equal to 0. So you do that, then you go and start factoring and see what what you come up with. Yep. All right, anything else before we look at another one like this? All right. So here, x squared minus 13x plus 36 equal to 0. Now we already have it set. We already have one side equal to 0, so that's not. So we're good to go. We don't have to worry about that. Looking at our factors of 1x is just x times x. So then we need our factors of 36, which is what I did over here. And say what factors of 36 that will add together to give me 13 in the middle. And that is 4 and 9. So that's how I got this expression or this factorization right here. Oh yeah. So before, remember our back sign was minus, so our signs were different. If your back sign is positive, that means your signs are going to be the same. And then this one lets you know which signs to use. So that's why both of them are subtraction. So you always start off with the back sign. If it's positive, then both of your signs should be the same. If it's negative, then both of your signs will be different. That's a new one. But it's all good. All right. So once you factor, you set each part equal to 0. And solve for x. Add 4 to both sides, add 9 to both sides.
So just to make sure, we could use any of those multiplication numbers that you gave for 36.
Yes, you could, but what dictates which ones you would use is the fact is the middle number right here.
Okay.
Right. So because 4 and 9 come together to give you 13, that's why you use the 4 and 9. Like if it was 20 in the middle, then I would have used 2 and 18.
Gotcha. All right. Thank you.
Not a problem. All right, everybody good? Before we do, I think we got at least one more like this. Yeah, one more like this, and then go from there. So next one. Once again, if we don't have 0 on one side by itself, we do need to make that happen. So that's what I did here. We have 9x squared plus 9x equal to negative 2. So we'll add 2 to both sides. And let me erase some of this stuff so it's clear what is what. Let's see. So we're looking at 9x squared plus 9x plus 2 equal to 0. Once we add 2 to both sides. So now, once again, if your back number is positive, then that means both of our signs are going to be the same. Now, our front, I said back number, but meant back sign, looking at the back sign. But since our front sign is positive, that means both of our signs will be positive. So that lets us know which ones our signs will be. And I need to look at my factors of 2 and factors of 9. So factors of 2, we don't have a choice. That's just 1 times 2. That's what I wrote right here. Factors of 9, 1 times 9, and 3 times 3. So those are our choices. And remember, what you choose will be validated by when you multiply it back out, does it give you what you originally had? You know, you can use, if I use 1 times 9, I can use that. I will get 9 in my first term, but will it give me 9 in the middle? And so that's why you always have to go back and check your factorization by multiplying it back out. So that's what I did here. I chose 3x and 3x. And then 1 times 2, like I said, there's no other way to get to but 1 times 2, so we didn't have a choice there. So now when you multiply that back out, okay, there we go. So we multiply that out, FOIL it out. That's what I did here. That gives me 9x squared, 6x, 3x, and 2x. Add the 6x and 3x to the middle, and that gives me this expression right here. So once again, you try out the factors of those, your front number and your back number, use them, then FOIL it out and see if you get the expression that you had originally. And that will always solidify if you got the correct factorization or not. The more, and then I'll say this too, the more you do this, the more you get comfortable with it, the less you have to keep going back and checking, because you'll know what terms will work and whatnot. You'll start to see things ahead of multiplying it out, and you'll know it, it just won't work, So the more you do it, the more practice you get with it, the less you have to put time in going back and checking and all the stuff like that. But if you're unsure, checking by multiplying it back out will always, assure you that you have the right factorization. All right, so 3x plus 1, 3x plus 2, set them both equal to 0. And solve for x. We get negative 1/3 and negative 2/3. Any questions? All right. So any problems before we go to the next method? All right, so the second method is the square root property. So it says if you have u squared equal to d and you want to solve for u, the way we would do so is by taking the square root of both sides. In order to get the square off of the square root, in order to get the square off of u, I would have to take the square root of both sides. So whenever you do that, on the side that it did not cancel, you will have to use plus or minus to signify that the square root of both sides had been taken, and your result will be 2 answers. All right, so you may say, well, why does that occur? So let's say if we have this x squared equal to 25, and I want to solve for x. Remember, your solution is going to be all of the values that will make that a true statement. So when I take the square root of both sides in order to get rid of this square, taking the square and the square root will cancel, leaving me with just x. But then you take the square root of 25. So taking the square root of 25, you're asking yourself, what 2 numbers times itself twice will give me 25? Well, positive 5 times positive 5 will give me 25, but also negative 5 times negative 5 will give me 25. So that's why we have to do the positive and negative when it comes to taking the square root of both sides. Because once again, positive times positive will give me the positive number. Negative times negative will also give me that positive number. So that's why whenever we take the square root of both sides, we always have to use plus and minus. So taking the square root of 25, they give me plus or minus 5. And so there go both of my answers Both my answers are being represented here. So that's the square root property. Whenever I take the square root of both sides, I have to use plus or minus. Any questions? All right, can I scroll up? So I had an issue with a student I had to take care of. That's why I just sent that text out to the testing center. Apologize for that. All right, so here we have 9x squared plus 25 equal to 0. Now, if we're trying to use the square root property in order to solve, what we want to do, if you notice what we had here, we have x squared, or whatever our quantity is, being squared on one side of our equation. So we isolate whatever's being squared on one side of the equation. As a matter of fact, let me do this. Do it like this. So I'm going to subtract 25 from both sides and then divide by 9. So this is when, like I said, if you want to use the square root property, that's what we're doing. We're going to isolate whatever's being squared to one side of the equation by itself. All right. So then take the square root of both sides. Taking the square root of both sides will give you plus or minus square root of negative 25 over 9. And then the result will be plus or minus 5i over 3. Square root of 25 is 5. Square root of 9 is 3. And once again, the square root of the negative will give us that I. Any questions?
I have a question.
Mm-hmm.
If this 25 wasn't negative, would it still be plus or minus?
Yes, it will still be plus or minus. It just would not have the I.
Okay.
Yeah. So it'd be plus or minus 5 over 3. But that negative in there makes us have 5i. Yeah. Good question, good question. So what made us have the plus or minus is the fact that we had to take the square root of both sides in order to solve for x. All right. Anything else before we do another problem that involves square root property? All right. So the next one, square root of x minus 2, or you can say x minus 2 squared, quantity of x minus 2 squared equals 6. So now the whole quantity of x minus 2 is being squared. So in this case, what is being squared has already been isolated to one side of the equation, so we're okay. We would take the square root of both sides because we need to get the square off of x in order to be able to solve. So we need the square off of that parentheses. So the result would be x minus 2 equal to plus or minus square root of 6. Finish solving for x by adding 2 to both sides. And that would be 2 plus or minus square root of 6. Now, in my math lab, I forgot whether they have the plus or minus symbol or not. I know at one point they didn't. I forgot whether last semester they added or whatever. But if they don't have the plus or minus symbol, then you have to just write both of them out. 2 plus square root of 6, then comma, 2 minus square root of 6. All right, any questions on that one?
So then when we're writing it out separately, if we do have to, it would be what, negative, then the square root 6, right? I just want to make sure this, the negative's not going to go underneath. Okay.
Yeah,
That's
it'll
what
be
all
like,
right, perfect.
yeah, it'll be just like that. Yep. All right, anything else? Anybody else?
So I got a quick question.
Mm-hmm.
So for instead of putting the square root to eliminate the power of 2, can you put it as x minus 2 times x minus 2 instead? Or
You will be using another method.
okay.
Yeah. So this, remember, this is if you are trying to use the square root property. But if you were to FOIL that out, you could FOIL it out, simplify it, then subtract 6 from both sides, and actually use our previous method of factoring and stuff like that. So now, well, you would try to factor, but because you can't factor, then these solutions let us know that a clean factorization wouldn't come through. So what we would do is we have to use one of our next methods, whether it be completing the square or quadratic formula. So yeah, but you can use other ways, but it's just that you wouldn't be able to use the square root property by going the route that you're talking about.
Okay.
Yeah.
I see.
All right. Anything else? Anybody else? All right, let's look at the next one. Let me erase this. So got to be something different. Okay, I see what's about to happen. Okay, so let's say we have x plus 4 squared equal to 81. All right, so the first thing we want to do, just like in the last one, take the square root of both sides. You take the square root, where's that? Square root of both sides. That would be x plus 4 equal to plus or minus square root of 81. Now the square root of 81 is 9. So that's what we have now. X plus 4 equal to plus or minus 9. So the square root of 81 is 9. And then from there, we can go ahead and subtract 4 from both sides. And that will give us this result right here.
It doesn't matter where we put the -4, right?
You just have to be careful with it. As long as it's plus or minus 9 and the 4 is negative, then you're still okay. But normally the -4 would go in front of the plus or minus. All right. So now, notice the difference between this one and the last one. The last one had this square root of 6 as a part of it, so I couldn't add or subtract 2 and 6 together. But this time I have 2 regular numbers, so you are expected to reduce that. So that's -4 plus 9, -4 minus 9. And then that will give us these 2 answers right here, which is 5 and -13. So if you have nothing stopping you from adding the numbers together or subtracting numbers from each other, you are expected to do so. So make sure you watch that. So here, up here is another example of when you could not go any further because you have a real part and imaginary part, can't combine those. So you would just do 2 plus or minus 6i. But once again, if you have regular numbers, you are expected to go ahead and add them and subtract them from each other. All right, any questions before we look at the next method? All right, so for completing a square, got some steps for you. It's a little more systematic. Yeah, so I'll give you the first three first, then we'll scroll down. So completing the square to solve ax squared plus bx plus c equal to 0. Notice it says equal to 0. So once again, we're going back to the idea that we have to set one side equal to 0 first. It says if a is not equal to 1, then divide both sides by a. In other words, divide each term. So that's what I was saying here, divide each term by a. So that means step 1 may not have to be done. It depends on if a is not equal to 1. Step 2, isolate c to one side of the equation. And we're going to talk about what all this means, with some numbers and everything in a second. Step 3, we'll take half of b and square it. Then the second part of step 3, we'll add the result to both sides of the equation. All right, give you a chance to write down those steps before I scroll up. All right, if I go up too far, let me know. And we're still step 2. All right, so that's the end of these steps. So we said step 3 already. Step 4, factor the perfect square trinomial, simplify the other side. Then step 5, we're going to solve using the square root property. And then step 6, the final step in all of your processes is to check. Of course, it's on you to do that final step, but if you do everything correctly, then you still should get the right answer. Some processes, I think we talked about one of them before, that even if you do everything correctly, you still need to go back and check to make sure that certain things work out because how you manipulate your problem. This is not one of them. If you do everything correctly, your answers should be correct. All right, about ready to try it out? All right, so let's look at these step by step and make sure we're okay. So the first problem, x squared minus 6x plus 4 equal to 0. Now the first step says if a is not equal to 1. So in this case, a is equal to 1. Remember, a is what's sitting in front of x squared. That is your a. So a is equal to 1. That means there's nothing to do as far as step 1 is concerned in this problem. All right. Step 2 is to isolate your constant. You want to move your c term, the term that's not attached to a variable, to one side of your equation. So I subtracted 4 from both sides. That is the end of step 2. All right. So now step 3 is 2 parts. You're going to take half of your b term. Your b term is what's sitting in front of your x. So we're talking about -6. We'll take half of that and square it. So that's what we did right here. Half of -6 is -3. -3 squared is 9. And then we will add that 9 to both sides of the equation. right, so before we go to step 4, any problems? All right, so now what we should have right here is a perfect square trinomial. And then on this other side, we should just have numbers that we're either going to add or subtract from each other, depends on what's going on. So -4, before I go there, right here, if you have trouble factoring, the way this always works is whatever half your B term is, that's what will go right here. So when you took half of your B term, that's always what's going to go there with the X in your factorization. And it's made for it to work that way. So that is why we will have X minus 3. So even if you have fractions involved, whatever half of your B term was, that's what will go right there with your variable. And then, of course, -4 plus 9 is 5. So any questions on step 4? All right. So now we can do the square root property. We can take the square root of both sides in order to get that square off of X minus 3. So that's what we did right here, taking the square root of both sides. So that'll leave me with X minus 3 equal to plus or minus square root of 5. Never forget, whenever you take the square root of both sides, plus or minus has to be involved on the other side, on the side that the square did not cancel out on. So that's why X minus 3 equal to plus or minus square root of 5. All right, add 3 to both sides, and our solutions, 3 plus or minus square root of 5. Any questions? All right, let's do it again. Everybody good with that? Scroll up. All right. So next one, 9x squared minus 6x minus 4 equal to 0. So this time a is equal to 9. So we will have to perform step 1. A is equal to 9, so we're going to divide each term by 9. And what's in the box is the result. So the 9's cancel on that first term to leave us with just x squared. And we have 6 over 9, which is 2/3. And then 4 over 9 is 4 over 9. Of course, 0 over 9 is 0. Any problems? Step 2. Process still is the same. We're going to isolate our constant. So we're going to add 4/9 to both sides. So it'll give us x squared minus 2/3 x equal to 4/9. All right. So this one could be a little tricky. So now step 3, don't forget the process is to take the b term, which in our case is -2/3, and take half of it. So if you're taking half of anything multiplication in mathematics, of is multiplication in mathematics. So if you're taking half of a number, that means you multiply it times a half. So that's 1/2 times -2/3. So if you want to reduce first, And then multiply we can, those 2's will cancel, leaving us with negative 1/3. And then negative 1/3 squared is 1/9. And then the last part, or the second part of step 3, is you take that 1/9, add it to both sides of the equation. All right, any problems with any of the steps before we go to step 4?
Could you add similar terms right now to simplify?
That's our next step, yes. I'm just doing them step by step according to the directions that they gave. But when you guys start doing it, y'all will probably just be doing it, however way you want to do it and however you see it. As long as you do everything correct mathematically, then you'll still be fine. I'm just breaking it up so that somebody can look at it schematically and just go step by step. But yeah, you most definitely could have went ahead and just added them together. Yep. So going to the step that your classmate just mentioned, we're going to factor this trinomial over here. And remember I said that if you have trouble factoring, whatever half your b term is what's going to go here with your x. That's why I drew those arrows. So half of negative 2/3 is negative 1/3. So that's why it's x minus 1/3. And then here, add these together. 4/9 plus 1/9 will give you 5/9. Questions? Did I hear unmute? Are we good?
Okay, so
Mhm.
if this wasn't simplified already, like if that 1/9 was like 2/18, right now, would we simplify it in that part?
Yeah, so you're saying if you have 4/9 plus 2/18? Is that what you're
Yeah.
talking about? Yeah. Yep. The only thing is that now you have to find common denominator, which would be, 18. And just go through that whole process. And that would be 8 over 18 plus 2 over 18, 10 over 18, and then reduce it to 5 over 9. Yeah. Yep. All right. Any problem with that before we look at step 5? All right. So now we want to get the square root, or the square off of the square root. So we take the square root, the square off of the quantity. So we take the square root of both sides. That'll leave us with just x minus 3 on the left. Then on the right, we take the square root of 5 over 9. Don't forget, if you take the square root of both sides, plus or minus has to be involved. And then also I can reduce this down further because I can take the square root of both top and bottom of your fraction individually. You only do that when, whenever you have a denominator, you do want to rationalize your denominator and make sure you don't have not a fraction, or radical still in your denominator. So taking the square root of 9 gives us square root of 5 over 3. So that's how you would do that. Then to finish it off, add 1/3 to both sides. And you can write your answer either one of these two ways. So we could do this because both denominators were the same. Don't forget though, if this was imaginary, I wouldn't be able to do that because they want the imaginary and the real part separate. So just throwing that out there. Any questions? Questions? All right. Let's see. It's 12:20. Anybody still copying before I go up? Very good. Let's see what's down here. Quadratic. We got 6. Yeah, I don't want to include this. Okay, so let's look at this last method for today. I was just looking to see if I want to push this off or what. Yeah, let's go ahead and look at quadratic formulas, our last method for today, and then we'll start clean in 1.6 on next class. That'll probably be the only section we do next class too. But yeah, okay. So quadratic formula, x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. You can pick out a, b, and c after you've ensured that one side is set equal to 0. So if one side is not equal to 0, then you don't want to pick out your numbers until you've done that, and then make sure everything is simplified as much as possible. All right. So looking at the first problem, using the quadratic formula, ax squared plus 2x equal to 1. So I don't know if I mentioned this. I kind of said it, but not really. These methods, all of these methods can be used interchangeably. If I took the last problem we just had and used the quadratic formula on it, then I still would get the same answer. Just what method you use depending on the person. Depends on which scenario gets you to the answer quickest. And stuff like that. But you have your options available to you. And so that's what, this section is about, showing you all of your options, depending on the, the initial setup of the problem and how you feeling, So here, 8x squared plus 2x equal to 1. First thing we want to do is to set one side equal to 0. So now we have 8x squared plus 2x minus 1 equal to 0. And once that is done, then we know what a, b, and c are. A is what's in front of x squared. B is what's in front of x. And then c is the term that is not attached to a variable at all. So, and also make sure you hold true to your signs. That's a positive 8, positive 2, and a negative 1. Then from there, we plug it into the formula. Make sure you don't lose a negative, when you go about plugging your stuff in. That negative b right there is a part of the formula. So if you end up having a negative b, make sure you keep your negatives, all of your negatives. So plugging in positive 2, we have negative 2 plus or minus square root of 2 squared minus 4 times 8 times negative 1 all over 2 times 8. So simplifying, 2 squared is 4. Negative 4 times 8 is negative 32. Negative 32 times negative 1 is positive 32. 4 plus 32 is 36 under the radical. Square root of 36 is 6. So now we have negative 2 plus or minus 6 over 16. And just like before, if you can add and subtract these numbers, then you are expected to go ahead and do so. I'm not scrolling up too fast. Anybody still copying that? Okay. So that'll be negative 2 plus 6 over 16. Negative 2 minus 6 over 16. And then that finishes off as 1/4 and negative 1/2. And then just to note that whenever your numbers come out as solid numbers like this, then that means you could have used factors, your zero factor property to solve. You could have factored it out. Yeah. long as there's no radicals still involved or imaginary numbers still involved, they come out as solid numbers like this, you could have factored those out, factored that equation out, or use the factoring process to solve. All right. Questions before we do another one? All right, so let's do it again. We have 3x squared minus 2x plus 4, 0 equal to 0. So we already have one side that is 0, so we don't have to do anything with regards to that. Remember last time the first step we had to do was, I believe, was subtract 1 from both sides in order to set one side equal to 0. In this case, we do not have to do that. One side is already set equal to 0. So now we can go ahead and pick out what is A, B, and C. So we see that A is 3, B is -2, and C is 4. All right. Once you've established A, B, and C, then you go ahead and plug it into the formula. There's a formula right here that doesn't change. But one thing you want to make sure you're careful about, and I mentioned it last time we were plugging in numbers, is that you don't want to lose a negative. So there's a negative or a minus B in the beginning of this problem, and that negative needs to still be there, but also there's a -2, so make sure you don't lose that as well. And the only reason I point that out is because a lot of people, make a mistake there, especially when they have a negative number for B, they'll sometimes forget that there was a negative in the formula. So just make sure you don't lose negatives when you go about substituting your numbers in. So that's -2 plus or minus square root of -2 squared minus 4 times 3 times 4 over 2 times 3. And negative to negative turns to a +2. -2 squared is a +4. Then that's -4 times 3, which is -12 times 4, which is -48. Any problems? Any problems? All right. 4 minus 48 is -44. And here in the green is me breaking down the square root of -44. Similar to what we were talking about before, when you have a number that's not a perfect square, but you look for factors of that number that you can take the square root of. So I broke up that 44 into 4 times 11. And we do have that negative under the radical, so we have to consider that part as well. So taking the square root of -4 is 2i, and you leave the 11 under the radical. So that breaks up into 2 plus 2i square root of 11 over 6. Any questions on that? All right. So break it up by shooting that 6 into each one of your numerators. So that'd be 2 over 6 plus or minus 2i squared root of 11 over 6. And then reduce them. That would be 1/3 plus or minus I squared root of 11 over 3. All right, questions. All right, so that is it for 1.5. Like I mentioned, 1.6, we'll do that or start that next class. Any questions on anything before we close out today? Everybody good, everybody straight. All right, so if you guys are good, I'm good. I think we covered enough for today. Didn't want to jump into 1.6, just to, because I know we're not going to finish it. And there's a lot of stuff, a lot of stuff in there that can stand alone in 1.6. So we're good to stop here. It's a good stopping place. And so if you have any questions, always feel free to shoot me that email. If not, feel free to ask it on next class. Outside of that, you guys have a great day. Be safe, and I will see you on Thursday.
Have a good one.
Thanks. You do the same.
As well, you as well.
Yeah, have a good
day, Professor.
Thanks. You guys take
Have
care.
a good day.
Thank
Bye,
you.
Professor.
Take care.